broadcast from Salt Lake City, from the offices of Torque3, and they are releasing their prototype, so you can see it in action, and it's going to be an exciting thing. And we'll be talking with their the scientists behind it, the physicians behind it, and the technologists behind it.
Okay. Sorry, I got a little voice in my ear. So, and we're really happy to have you guys from Innovator MD and really come out here to our prototyping shop. I don't know if the cameras have shown it yet, but we've got a really nice group of people, both from the local area. As far away as Montana, we have somebody who's had a TBI, state trooper, had a TBI. He's going to try our session here shortly. And we've been making some phenomenal progress in the last 5 months since we moved out here from the Silicon Valley, building a new prototype. So it's really difficult when you're going to see some of the footage you're going to see coming up to understand what it feels like. Yeah, it looks cool, but it feels amazing to be in there. The level of immersion, how people get lost in it and have some a perception of risk, so we can assign urgency and importance to the tasks they're doing. How the robotics work to compensate for any impairments. So these are the kind of things you really aren't going to be able to get any feel for while watching the video. But I think maybe we'll do some interviews afterwards of people who've been on it, so you can talk to them, get their impressions, and see what they have to say. We've got some. I think we've got a stroke survivor here. We've got a TBI survivor. We've got quite a few clinicians that are trying it out. And this product, this is the, what you're looking at here is we've just finished putting this one out about 3 or 4 days ago. It's our P2 T prototype, the test wheel prototype for the technology testing, where we're running the latest and greatest of our sensors and computer and programming on. But it's not really going to be an MVP. The MVP is coming in Thanksgiving, and we're going to be going out to the market with a pilot program after the first of the year. So really excited, phenomenal to have you guys out here, and I'm going to hand it back off to Yuli. So I'm getting home battery. Here you go. Low battery, yeah, of course. Low battery, right? Yeah.
Okay, good thing is you can see the video of the person trying. So he's sitting in the machine. So the machine itself is a robot. So it measures every movement, the strength that you're applying at each joint. And so it looks more like a quad. I don't know what they can.
Check.
Right, he's putting on a VR headset. So what he can see is it'll transport him into a video game environment. And when he goes there, he'll be riding this vehicle through different settings, so through different areas. When that happens, the machine is measuring all the pressure, the movement, and how much effort, and what kind of reaction time he's having while going through the environment. So imagine this, if you're a person with a stroke, the weak side will still be able to move because the robot will push the weak side. It'll compensate for the weakness. And the good side will actually keep the patient moving. And I'll show you what the background looks like here. So that is what the patient is seeing when they are riding the machine. So they are actually going through a trail, through the woods, and he's trying to navigate. So that's what the patient is seeing. So what it does is it creates an interesting urgency, an interesting stressor for the patient. The idea is when you put a patient in this kind of an environment, it will stimulate neuroplasticity. When you stimulate neuroplasticity, the idea is that it'll create new neural pathways so that you can improve the recovery of the patient's deficit. So here is Dr. Tim Lacey, who is our Chief Science Officer, and he will explain to you what neuroplasticity is.
Okay, so now I got this going on. Okay, so our system, we say it's multimodal and it enhances neuroplasticity. And here's how we think about that. If you bear with me for a second, I'll start with development. When we're little, as we develop various neural structures, we learn immersed in an environment. We're bombarded with sensory information. We're moving, we're getting feedback from our movement, all of that in real time. So as I learn to move my arm, speak and so on, it's all in the context of being immersed in the world. Well, all of the processes, when it comes to forming neurons, growing dendrites, so on and so forth, what we do every day to grow and adapt, that's all neuroplasticity. When you injure a brain, the way you start healing that is through neuroplastic changes, first locally, and then it spreads out. And you can even recruit neurons from the other hemisphere to help recover the functions of the areas that are damaged. And what we hope to do by placing someone in a completely immersive experience that's synchronized with movement, with the immersive stimulation.
Can you hear me, Richard?
Oh, I can hear something. Okay.
Yes,
right.
Eric, I can hear you.
Good. Okay, we on? Sorry, I was just hearing a little something. Okay, all right, okay, good. Well, by placing someone in this immersive environment, we hope to simulate what we experienced when we were growing up. So as you develop, you know, you you become the avatar, you become that body, and we want to facilitate the healing of those neuroplastic processes immersed with all of the sensation engaged.
Right.
And motor feedback, all that. So there you go. Thank you.
Thank you very much, Dr. Lacey. That was a great explanation of how it works. I was trying to do it, but you know, he's much better at it. One of the beauty of this machine is that this is just the beginning of what is possible. So here to explain to us is Dr. Joey. Can you explain to us how this thing works in real life?
Well, so my name is Joey Kamerath. I'm a physical medicine and rehab physician. I'm really excited about this technology. So there is a lot of excitement about robotics and rehab, and some of it is good, but really most of the medical evidence behind robotics and rehab is something called non-inferiority studies, where we take a piece of technology and we compare that to standard of care. And people say, look, we had this great success story. This piece of robotic technology is non-inferior to the standard of care. And I scratch my head as a physician and I say, well, why don't we just do the standard of care then? It's a lot less expensive. But fortunately, the tech is getting to the point to where we really believe that it will elevate the standard of care beyond just basic standard of care. This is never going to replace good therapists. We need good therapists in neuro rehab to help diagnose and treat patients. But there we go. This is a really unique technology which brings together all brain centers simultaneously and helps engage the patient in a way, in an environment that's fun and in an environment of perceived danger. So if I have a stroke patient, they already tend to kind of be bummed out. You can hear the excitement about the machine back there. It's getting pretty loud. It's hard to stay motivated. Even just the effect of the inflammatory response of a stroke makes someone not want to participate in life or rehab. when we have technology that's exciting, they're way more likely to be engaged. And when that technology is stimulating multiple brain centers at the same time, we believe that that accelerates neuroplasticity and recovery. So we know that the brain changes and can recover from injuries. We believe that this system is the ideal scenario for that. If a physical therapist is working with a patient and trying to push them to the edges of their balance and trying to help improve their balance and reduce their risk of fall, that can be done safely in a gym, and we do that all the time. But usually they're getting those repetitions on a fairly infrequent basis. So if a therapist is working with a stroke survivor, they might almost get to that point of falling a couple times a minute safely. And we think that those repetitions help them recover more quickly. In this environment, we can push them to the edge of balance and their perception of falling, where they recover their balance multiple times a minute. And so those reps are what we think help accelerate the rehab. And this, like I said, this isn't going to replace good rehab, but man, 20 minutes on this machine in a 1-hour neuro rehab session, we think will do a lot to augment a strong therapy program from a qualified healthcare provider. So we're really excited about it. Of course, we're looking forward to getting to the point to where we get some independent third-party evidence to substantiate what we believe this will do. We're not there yet, but we're getting closer to it.
Thank you. Thank you very much, Joey. Are there any questions? Let's see. I assume that the machine configuration can be tailored to different kinds of patients, different kinds of problems. Can you explain that?
Sure. So I'm getting a little bit of echo, so I'm going to back up from you, Yuli. So we anticipate nobody's body is the same. And so the boom is built so that the leg length can be different, the arm length can be different. Sometimes stroke patients have shoulder instability. And so we need to be able to pull the shoulder closer into the body to compensate for that instability. So the mechanics of the machine facilitates different abilities. We really see that this has a huge application for neuroplasticity in the brain injury and stroke population, but there really are applications that could go much beyond this.
Thank you very much. I think we can cut from here. We will see if there are anybody else who is trying the machine. And Eric, can you show the machine? I'll take questions from here. Let's see, there is a chat question. Let's go there.
Testing 1, 2, 3, check. Can you hear me, Dr. Julie?
Yes, I can hear you, Eric. But let's see, any other questions about this technology? Sorry, I missed the last part because I logged out of my laptop. But if there's anybody can raise their hand, and I'll see if I can answer those. There's a new person now trying to get the machine on. So they're putting on the VR goggles. And these systems, you know, the VR, the scenarios that they're building with this is amazing, because you can actually feel that you're in that situation, you know, whatever environment. It could be a forest, it could be an ocean, it can be in the air. But the idea is to create that situation where the patient feels that they are in that real environment.
Yuli, there's a question in the chat.
Yeah, I see that.
That patient in the machine. Yeah. Before that, there's another question.
Okay, what is
that patient in the machine does not look like somebody with a rehab need.
That's true. Have you, so the question is, have you tried this machine on actual stroke patient? So today is the first day that we have actually tested it on stroke patients. We had 2 people, one with stroke and one with head injury. And So this is how the computer looks. I'll turn around so that you can see the computer. Right now it's blank. There you go. That's the environment that the patient is seeing through the VR. And we can see on the monitor up front. So they're trying to get out of this parking lot. And soon they'll be going into the forest there. So that's exactly what they're seeing in there. Of course, it is a VR environment, so they can see all around. They can look at the sky, they can look at the trees, they can listen to the birds, because now they're wearing headphones. And so it is a very totally immersive situation. Now, when they're going on rocks, they can feel the machine bump. When they're going on sand, they can also feel the sand or water. You know, it feels like you're going in a real environment. So the vibrations that you get from the machine are very real. The other question here is, let me see. Are the tracks, paths, preset determined to need for the rehab? So right now we have a few tracks. So the idea is that we will be doing some pilot studies to see what kind of track, what kind of situations would be ideal for different kinds of neural deficit, right? So the path, you know, you can, of course, you can change the environment like you could change any other video game environment. So it's a very easy thing to do. And we can actually create customized tracks for different disabilities. Let's say if there's a kid or a young adult who's going through it, you know, we can create something more interesting for that person. What is the pricing? Are you working with payers or providers? Well, right now we haven't priced it yet. But as you can see, so one of the other beauty of these guys, this team here, is that they're actually building a lot of the parts here. I'll show you the workshop where they actually have these machines where they're building these, you know, lathe machines, you know, 3D printers, all kinds of production equipment at this workshop. And so a lot of the parts are made here in Salt Lake City. And that's why they were actually in the Bay Area when I first saw them. And then they moved here because obviously, you know, the cost of, you know, working is much cheaper here in Salt Lake City. Plus, they have good access to rehab centers here. And there's some good healthcare people here that they can access. So what is the pricing? Oh, so to build something like this, for them, it is costing about $40,000 to $50,000 each machine. But once they start to, you know, get into production, it will be probably half of that cost. The other question is, are you working with payers and providers? Not yet, because we need to first, you know, build these prototype machines which can go into a pilot study, do some trials, clinical trials, and kind of fine tune that machine. And so it takes some work, but today's the big deal is that this is, you know, patient ready to be tried with patients. Will the machine and VR glasses always be paired together? Yeah, usually, you know, they have a set of VR glasses, I think. I assume the machine configuration can be tailored to different kinds of patients. Yes, yes, yes. So the first clinical application they will be trying on is for stroke patients. You know, as you know, stroke is a pretty devastating disease, and they feel that if you attack early, if you treat these patients early with this kind of an immersive situation, you can make a much better recovery, much faster. Lawrence asks, if the patient's one leg is completely paralyzed, either from stroke or spinal cord injury, does the machine move the paralyzed leg? That's exactly the point I was trying to make. Yes, it does move because it is a robot, right? You know, if you don't move, the machine can recognize that you're not moving a certain part, and it'll help you. It'll help you to a certain degree where the patient feels that the patient feels whole. So the patient does not feel that they have a paralyzed leg, although they'll be moving the leg with the other good leg, and they'll be moving the pedal with the good leg, and the machine will be helping the paralyzed leg. And so the idea is when you start collecting this kind of data, you know, I think some 10,000 data points in each session, in a 20-minute session, you can collect that, right? And then all this data goes into the cloud. And imagine if you have 10 patients on 10 different machines, and you're collecting this data and you're tracking patients' recovery. Now, this machine can also measure the recovery, because when there is a weakness, it can also notice the recovery. And the program, you can automate the program in such a way that it can let the paralyzed leg work a little bit, and then you can dial it up or down, how much resistance that paralyzed leg will feel. Of course, not necessarily, you know, the whole, you know, if it is totally paralyzed, we hope that it won't put any resistance on that paralyzed side. But if it is partially paralyzed, or if it is recovering, then you can put some resistance and expect the brain cells to get activated from that. Let's see. For the Torque3 team, is the patient user hooked up to a blood pressure monitor? No, not right now. Let's see. I guess I've answered all the questions. Well, okay. So it is almost time for us to end. If there are any other questions for us, please, you can put it in the chat. I'm here. I can catch one of our specialists here. Otherwise, I'll try to answer them. But otherwise, we can keep this live feed on for a few more minutes while you watch these patients use this machine. And if you have any questions, you can always connect with me or David Elzy. I'll put his contact information in the chat here. Elzy. So you can find him on, he's the CEO of Torque3. You can go to the website, or you can find him on LinkedIn. Let me show you the Anadia or Ruchi, can you pin the Gamma Productions, the video on there?
It is already pinned, Yuli. It is already pinned.
Okay, so that's exactly what the patient is seeing right now. Great, thanks. Okay. Okay, looks like the patient just stopped. So the machine, I think he's getting down. Okay, so that's what is happening, folks. Let me see if I can.
Right. And so that's why your highlights were your chest and they dropped. We didn't know that. So.
Can I ask you a quick question?
Sure.
Okay, this is the microphone.
Okay.
Earplugs. So talking to the microphone and tell us what was the experience like?
It was fun. It's I like when I ride the bike. I like to look at the scenery, and it was interesting because some of the bumps bigger than I expected they would be. But you're using your arms, you're using your legs, you're getting the visual input, the sound, audio, and also you get the feeling of the physical movement. As you hit bumps, as you went around the corners, you had a sense that you're actually moving. I guess the only thing it's missing is just some wind.